Alright guys, um, just wanted to introduce a prototype I've been working on regarding an ethanol content analyzer. Um, this is mainly due to my preparation for my E85 conversion for my 2015 STI. So I found out that during this preparation, found out that some of the, majority of the ethanol content analyzers out there are really expensive. So they range from, I found, from between $350 to about $500. So, but I did a lot of research in terms of what they did, what sensors that they required, etc., and just found out that it wouldn't be too hard to actually design something and really put together something that was a fraction of the cost that was out there, and you can also provide some additional features onto it. So, so with that said, I'll go ahead and get started with the demonstration. So, and as you can see, I have the flex fuel sensor here. So what it actually does is that it measures the ethanol content and outputs basically a square wave of signal, which basically ranges from about 50 hertz to about 150 hertz. So, and typically when it senses any fuel contamination, it usually outputs about 190 hertz square wave as well. So for this demonstration, we're going to basically just use a function generator in place of the flex fuel sensor because, well, the fact that I don't have E85 and gas right now, or E10 gas right now, to really try out the demo. So with that said, we'll just go ahead and use the function generator at the moment. So, alright, so what we had up here is basically, as the main control unit, I'm currently using a Picket 3 low pin count demo board, which pretty much uses a PIC16F1783 8-bit microcontroller. So on the left hand portion, I'm currently using a 8x2 LCD as basically for my display. And so basically I really wanted to put together a design two applications. One is basically using an LCD as a display unit, and then the second one is basically making use of a Bluetooth comms that I can communicate to a tablet or smartphone or something of that sort. So with that said, those were the two options I really wanted to explore. So last but not least, I have the ISSC evaluation board, which has a BM77 module. It's basically a dual mode Bluetooth module, which can operate both either Bluetooth Classic and as well as Bluetooth Low Energy. So this kind of gives me wider range in terms of covering all these different products out there, from legacy and up to the latest and greatest Android and iOS devices here. So, alright, so without overdue, let's get started with the demo. So as you can see, I have a function generator here which outputs a 50 hertz square wave signal, and as you can see, I can verify my oscilloscope on here. So 50 hertz, set up a 50% duty cycle. So what I'll do, I'll go and power up the unit. There's my LCD display here. So as you can see, top line displays my frequency in terms of hertz, and then on the bottom line is basically my ethanol content here. So now to kind of simulate ethanol content of roughly about 85, I found out with characterizing and playing around this sensor, it typically is around 135 hertz. Alright, so 135 hertz, that yields me roughly about 85-86% ethanol. So as you can see, 134 hertz, 135, so it's pretty close. And a real nice part about this the LCD demo is that you can also toggle between the minimum and maximum. There you go. Ethanol content. So, all right. So let's get this set up to where let's default this back to about 50 hertz so I can demonstrate the Android app that I put together for this board. So now we're set to about 50 hertz. So what I'll do, I will use my other phone here, and we'll go and open up that app which I've designed. Alright. So you can zoom in on that thing. So that's the app I put together. I click on it. Alright, so the app is it's a little bit more feature pack in comparison to the LCD application. So as you can see, this one provides in terms of course your fuel composition, your percent ethanol in your fuel. Also tell me whether or not your fuel is contaminated. It'll display other parameters like, for example, your input frequency that's coming out from a flex fuel, an analog V out, which I put together using a PIC, which outputs the PWM signal to an RC filter. So this V out can be basically tapped for systems that we required to, they can change these fuel and timing maps according to the ethanol content. So, and of course it'll display some fuel temperature, which I'm trying to work out at the moment. Oops. Alright. And of course the minimum and maximum values of my ethanol values here. So of course you have the option to reset values. You can also search for other BT or Bluetooth devices, or disconnect from one, or as well as kill this application. So alright, now what we'll do is basically we'll search for a Bluetooth device. As you can see, came up with several options or Bluetooth profiles here. So currently what I have this set up, this module is named after my daughter, which is Lila. So I have it set up as Lila. I'll select it.
Bluetooth Ethanol Content Analyzer brought to you by RG Engineering.
Well, there you go. So I have this app pretty much set up to provide some text-to-speech, and just to make it kind of fancy and more creative. So as you can see, my output from the function generator is about 50 hertz. And it's pretty close to it as well, 49 hertz. And I have a fuel composition of about 1% ethanol. So, and of course our analog V out fluctuating between 1.5, 1.6 volts, and of course showing both my min and max ethanol values here. So what I'll do is that we can go up a couple steps before. So I'll jump up to about 100 hertz. And that should yield me roughly about 51% ethanol. Okay, now what we'll do is that we'll jump up to 135 hertz, which is basically 85% ethanol. Did I press it? Oh, okay, so 135. Alright. Alright, so 135 hertz. Okay, excellent. And of course you have the option to reset values too, so I can reset values right now. There you go. And one thing that I also like to show is that keep in mind that if the flex fuel sensor is found out that there's some water in the fuel, then basically it'll flag you down that your fuel is basically contaminated. So, and typically what that happens is that when it senses any water, it'll output a signal about 190 hertz.
Contaminated fuel.
So as you can see, as soon as it reaches that range, I have the app set up to where it'll prompt you, hey, your your fuel is contaminated. As you can see, the voice prompt that just happened, a few seconds ago. But as you can see, it tells that your flex fuel composition is out of range, and of course your fuel is contaminated. And also, more important, your V out is going to be disabled as well. So, well, alright, so that pretty much sums it up for now. I know that currently this is just the prototyping stages right now, but next step is to basically get this laid out, and then we'll get it all buttoned up, do some final tweaks to actually to the app itself. But I think we're pretty close to putting together a pretty cost-effective and jam-packed featured Bluetooth content analyzer here. So, alright, so thanks for checking out the vid. Appreciate it. Stand by for some more updates on this particular product. Alright.